In our last video, we talked about how to take the force that an object has exerted on it. So if you had a car and it's, 1,000 kilograms, and it's pushed with a force of 50 newtons, and it moves a distance of 10 meters, we can find the work done on the car. The work is equal to the force times the distance it moves. So in this case, the work is equal to the force, which is 50, times the distance, which is 10, right? So we gave the car 500 joules of energy. But what does that mean, that we gave the car 500 joules of energy? All right. What did the energy become? Well, the car is now moving. When an object is moving, it has something that we call kinetic energy. All right, it's just a type of energy. So we gave the car 500 joules of kinetic energy. So now it has 500 joules of kinetic energy. And we can do a lot with that, because kinetic energy has a formula that pops up a lot, which is 1/2 mass times the velocity of the car squared. So since we know that the kinetic energy is 500, right, that has to equal 1/2 of the mass of the car, which is 1,000, times the velocity of the car squared. So we can work backwards to get its velocity. So we divide over the half, we get 1,000 equals 1,000 v squared, which is going to be over here. That's going to be 1 equals v squared. Square root of 1 is 1. So we know that this car is going to be moving 1 meter per second after we pull it 10 meters with 50 newtons of force. That's the speed of the car. That's kinetic energy. We can work any direction you want to work. So if I tell you a car, okay, it has a mass of 500 and it has a velocity of 4 meters per second, what's the kinetic energy of the car? Well, the kinetic energy is going to be 1/2 mv squared. So it's going to be 1/2 mass of the car, which we said was 500, times the velocity of the car, which is 4 squared. We're only squaring the 4. So that ends up being 250 times 16, which is actually a little harder to do in my head than I thought it would be. I think it's going to be like 4,000, if I'm not mistaken. 4,000. And we're talking about energy, so it's still joules. So you're able to just plug in the numbers and solve for the energy. Or if you know the work, you can do it this way. So remember, work can be positive or negative. So suppose we had a car that was moving that 4 meters per second. So car is still moving this way at 4 meters per second. And it's still got a mass of 500 kilograms. And they slam on the brakes. How far is it going to take it to stop? Okay. How far is it going to slide before it stops? So we're looking for is x. We're looking for the distance. But what do we know? We know the velocity. We know the mass. So we can get the kinetic energy. 500. Oops, I forgot the 1/2. So I'll put the 1/2 right here. Times 4 squared. So we still have a kinetic energy of, what's that going to be? 4,000 still. So the distance it's going to slide. Well, distance, when we're talking about energy, always shows up in work, right? So work equals force times distance. And we know the work we need to do. How much work do we need to do to stop the car? Well, if the car stopped, we have to take away all of this energy, which means that we're doing negative work. We're taking energy away from the car. So we have to do negative 4,000 joules of work. Okay, and I forgot to tell you the force of the brakes. We'll say the brakes have a force of 10 newtons. They're really weak brakes. So that means that brakes have a force of 10 newtons. So how far are we going to slide? Well, 4,000 divided by 10 equals x. So we slid 400 meters. Well, it says negative because the force, the brakes, remember the brakes are trying to stop it. So there's a force of the brakes. And we said that those were positive. So if this is positive, that means that this direction this way is negative. So that's why we ended up with a negative number, because we called to the left positive. All right. So kinetic energy and work are directly related. It's sometimes called the work energy theorem, where work equals your change in kinetic energy. So work equals your kinetic energy final minus your kinetic energy initial. And remember that, so work equals 1/2 mass of the object. The mass doesn't change. So it's really going to be your final velocity squared minus 1/2 times mass times your initial velocity squared. So any of these will work. If you know your kinetic, excuse me. If you know your initial and final kinetic energies, you can use this one. If you know your initial and final velocities, you can use this one. Whatever you need to do. Work equals your change in kinetic energy. And work is equal to force times distance, which equals change in kinetic energy. So using this equation, you can solve just about anything with work and kinetic energy. All right.